Welcome back, my dear friends. A very good morning, good afternoon, good evening to all the students for the TQM2 subject lecture under the NPTEL MOOC series. And this is, as you can see, this is the 33rd lecture, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we are basically deciding on the higher factor models. Higher means more than 2 levels of dependence. Like the factors can be k, but the different levels of importance, different levels of effect, different levels of combinations between the variables or the attributes, because they can be quantitative as well as qualitative, can be 3, can be 4, can be 5. So, fractional factorial models would be 3 to the power k, 4 to the power k, 5 to the power k, and so on and so forth. And then later at part of the 32nd lecture, we consider the blocks, as that you can basically differentiate the overall effects in different combinations of, say for example, A, B, C are the variables. Whether attributes or variables are not the important question. So, how you divide them into blocks and basically continue your analysis, as that your main task is that if you please forgive me, I am repeating it time and again, I did mention that the issue is basically to find out the different variables. So, in the chart if you look, the different type of variables in different type of combinations, whether they combine effect, individual effect, then try to find out the concept of how the total sum of the errors would be there for each of them, considering then their third column would be degrees of freedom, then the f value, and based on that f value pass a decision whether you want to accept or reject that idea or a hypothesis, based on which you will basically say that which factors are important, which factors are not important at a certain level of confidence. So, that will also be coming from the p value. In between, we consider the folding effect, we consider different type of regression models. Regression models were basically of first order, it will be of second order, third order, depending on different combinations of variables you have. And then we were required to find out the coefficient of the regression models, and then we had different assumptions for the errors. So, all these things kept arising time and again during our discussion. So, we will continue the same analysis considering different concepts, but the general properties, general assumptions always remain the same. So, we now look at the slightly more complicated 3 to the power 3 factorial model. So, obviously, there are 3 factors at 3 levels. So, again they can be -1, 0, +1, 1, 2, 3, whatever, and they are confounded in 3 blocks. So, you will basically have the blocks, those vertical silos inside which the effects amongst themselves will be combined in such a way that the interrelationship between the blocks would be so called minimized, but obviously you will try to maximize the overall dependency structure when you are considering these ANOVA models. So, there are 3 blocks of 9 runs each. The A, B square, C square component of the 3 factor interactions would basically be given as the contrasting model, where the contrasting model will basically have x1 plus 2x2 plus 2x3 depending on the powers of B and C which you have. So, if it was basically A, B square, C square, D square, it would be x1 plus 2x2 plus 3x3 plus 2x, sorry, my mistake, 2x3 plus 2x4, and so on and so forth. It is easy to verify that the treatment combinations. So, now we are considering the levels as 0, 1, 2. So, the at the level when it is 0, 0, 0, which means x1 is lowest level, x2 is lowest level, x3 is lowest level, x1, x2, x3 are basically A, B, C. So, if the other combination can be 0, 1, 2, that means low, medium, high. I am talking respectively of A, B, C. It can be 1, 0, 1, which is medium, low, high, medium, low, medium for A, B, C. So, belonging to this principal block, the remaining runs in the principal block are generated accordingly. So, you can find for the first one it will be 0, 0, 0, in the first block you have 0, 1, 2, 1, 0, 1, and the combinations which you will have for different blocks, that if you consider the second block, the first element, even though the word first element may not be right, but I am trying to basically highlight the fact what is of interest to us. So, in this block you will basically have A at both the levels at medium, and then basically the combinations of B would be at low, C would be at medium. So, it is basically 2 0 2, then you have basically 0 to 1, then you have basically 1 1 0. In the third block you have 1 2 2. So, the levels means A as medium, B and C at high, then 2 1 1 would basically means A at high, B and C at medium, and the third one is 2 2 0, which is A and B at high and C at low. To find the runs in each block, note that the treatment combinations of 200 in the is not in the principal block. So, obviously, you have to take decisions according. So, these are what we are talking about. I will try to use another color. So, the blocks 1, block 2, block 3. So, if you consider this 200 effects or the combinations which we have, so this one 200 is not in the principal block. Principal block means where I am hovering my cursor. So, these are basically block 1, block 2, block 3. So, let me continue reading it. To find the runs in another block, note that the treatment combination of 200 is not in the principal block. Thus, the elements of the block 2 would basically now correspond to the value of 200, 212. So, I am reading the numbers basically to denote the level of importance of ABC. 200, 212, 001, 102, 221 or 221, 010, 022, 111 and 120 or 120. Notice that all these runs basically for mod 3, hence the final block is found by observing that 100 does not belong to this block of 1 or 2. So, using that we find out the combinations now as corresponding to, so this would be 1, this would be 2 and this would be 3. So, technically we can have the blocks accordingly defined. So, once we have the blocks, so in the 3 models, so the blocks are given as 1, it is mentioned, but I am just writing this is 2 and this is 3. Now, remember that you have basically 3 blocks with their level of importance. Level of importance means I am not talking from the word using the word from the English language sense, but it basically gives you the level at which each of these variables A, B, C, because this is a combination of 3 where there are 3 parameters or 3 variables or 3 attributes, whatever at 3 levels of significance. So, if we combine them and we try to plot them, you obviously will have a 3D diagram, and the 3D diagram again I will repeat it. So, along the x axis, which is my right axis, which is my left arm, which is vertical, right arm is basically horizontal, and the z axis, which will be either going from the point where both the right arm and the left arm meet, either towards you or away from you, and they are all orthogonal. So, basically it is considered in a room. So, at the corner point you have the axis going up towards the floor, another 2 going orthogonal along the towards the roof, and other 2 going towards the floor. So, the blocks combinations would be, if you basically denote block 1 as denoted as 000, 012, 101, 202, 2021, 110, 122, 211, 220. So, these blocks which you will have would be, I will mark them, there are this, 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 this. So, you have basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, if I use the other combinations, why I am drawing it with a different color, that you will understand the overall layout or the sequence of how the blocks 1, 2, 3 have been done. It obviously can be more than 3 blocks depending on what is the fractional factorial models which you have. If we say for example n to the power k, so obviously n would be the level of significance for each of these k factors which you have. So, I will use for block 2 the green color. So, the blue one which I have is basically for the blue, then I will erase this. So, in order to make our life simple for understanding, So basically you have the so this is block 2. So block 2 would be the total weight 1, 2, then you have 3, you have 4, you have 5, you have 6, you have 7. Where is 1, 2, 3, 4, 5, 6, 7, and where are the rest? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be on. Let me check. So you have. Let me check it. So it's easier for. So 200 is. 200 would go for block 2. So obviously this is marked something wrong because this should not have been block 1. Wait, let me go for it for the other block which is green in color. So this I will. So this is 3. You have 100. So 100 would come here. You have 112. It will come here. You have 201. 201 will come here. This is 002. 002. Okay, it has not been. Level of 0, 002. Then you have 121, 1. Then 121. So you will go 1 here, 2 here, 1 here. This one. Then you have 210, 210. Then you have 222, 222. You have 011, 0, 11, and finally 0, 0, 200, 2, 0. So you have how many yellow? 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I check the block 2, let me go through. So I am taking time. Please try to understand that. My apologies for that. So this is for the yellow one, and if I do the green one. So 200. So let me first erase because or else it will get confusing. Okay. So now I go to the highlighted green. 200. If we have 200. Okay. So this would be. So this should be highlighted with 200, green one, 212, 212, 212. This is also my mistake. This should be. That is, so the written one and the diagrammatic one, there is a problem. So I am trying to rectify that. Please bear with me. 001, 001 again an error. 001, 102, 102, 1102. This one. This should also be. Color should change. Then you have 221, 221. Yes, this is fine. Then you have basically 010, 010, 010. So this should also be removed. Then 022, 022. 022. This one you will have 022. Then you have 011. You have 011. This one. So this should 022. 111, sorry, my mistake. So it's 120. So the last one would be 120. So this is would also. So I think this should be done. So you have 022. Let me mark it. 022 is here. I am going through this. Then 212. 212 is here. Then 102. 102 is here. Then 221. 221 is here. 111 is here. Then 001 is here. Then 010 is 010 is here. Then 120 is here and 200 is here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are for the green one for block 2. So block 2s are given. So the color scheme here, there is a problem which I will basically highlight. The problem basically is here, the way of denoting. And if I go to block 1, so block 1 would basically be 20202. Block 1 would be blue in color, so I will basically go to the blue color scheme. 000 is here, 012, 010, 012, 012 is here, 101 is here, then 20202, 202 is already done, 021, 021 is here, 110 here, 122 here, 211 here, 220 here. So technically you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is done. So only in the nomenclature there was a problem in the circles. So one was basically dark circle, one was absolutely unfilled circle, and one was half filled circle. So the nomenclature was wrong. Anyway, I am sure you have got it. So it can be expanded from third dimension to fourth dimension, and you can make it more complicated with more number of factors, more number of variables. So you have to just analyze it accordingly and divide the blocks accordingly. So ANOVA, or the analysis of variance for the design, is shown in table 9.5. So through the use of this confounding scheme, the information on all the main factors and two factors interactions are available or is available. The remaining component of the three factor interaction, which is basically ABC. So at each level of importance being of first order, ABC, AB square C and ABC square are compounded as an estimate of the error, and based on that you again do the same table. I am repeating it. First the factors or different combinations, then the sum of the squares corresponding to those factors, and then the degrees of freedom, and then the F value and the P value based on which you will take a decision. The sum of the squares for those three components could be obtained by subtracting in general. So basically what you do is that the sum of the total errors should be the total sum of the squares including the errors. So obviously you want to minimize the errors. In general, for the 3K design in 3 blocks, we would always select a component of the highest order interaction to confound it with blocks. The remaining unconfounded component of this interaction could be obtained by computing the K factor interaction in the usual way and subtracting from this the quantity, the sum of the square blocks, and so on and so forth, and basically you do the combinations accordingly. So now is basically the ANOVA, the analysis of variance for the 3-3 design, and with A, B square, C square confounded. Now that means you are trying to basically find on the maximum effects from there. So the blocks are for A, B square, C square, the degrees of freedom is 2. I am just reading the first column and the second column. For A, B, C, the corresponding degrees are 2, 2, 2, and for A, B, A, C and B, C, the degrees are 4 each, and the errors obviously would be the total sum minus the degrees of freedom for the others combined. So, it is 6. So, your total number of degrees of freedom would be 26. So, 26 is basically you are trying to find out the sums, and based on that, and degrees of freedom would also be important, because once you find out the total sum of the squares for each of these. So, obviously, you will denote it as SA. Okay, I should use a much more pointed writing, so easier for me. Yes. So, this sum of the square of the would be SA, and this would be SA. I am just giving you examples. So, obviously, the second one would be S suffix B, third would be S suffix C, fourth I have written as S suffix AB, and the just before the errors the suffix would be S suffix BC, and correspondingly the degrees of freedom are basically given. The T3K factorial design in 9 blocks. So, we could choose 2 components of interaction, and as a result 2 more will be confounded automatically, yielding the required 8 degrees of freedom, and corresponding to that we can do it. These 2 are the generalized interaction of the 2 effects originally chosen. So, in the 3K system, generalized interaction of the 2 effects. So, example, you are defining them as P and Q, they would be PQ or PQ square or P square Q, and corresponding to that. So, because why it is basically 3K, because the total sum of the powers for A, B, C or P, Q would basically take as 3. So, if it is P square Q, so it will be 2 plus 1, it is P Q square, it will be 1 plus 2. In case if we have to say, for example, the 4 fx, so obviously it could be given as P square Q square, because that will be 2 plus 2 is 4. The 2 component of interactions would be given. So, now for mod 3 different way of mentioning, you would basically have the fx given as alpha 1 x1 plus alpha 2 x2, and obviously it will be alpha k xk, and in the other way of defining, so it will be beta 1 x1 plus beta 2 x2 plus dot dot till beta k xk. Now, the reason why they have been given a different parameters with xn and x1 in both the cases, or it could have been given as y1 in first case and x1 in the second case. The suffix 1 I mean that it would be in the first case it will be y1, y2, y3, y4 till yk, and in the next case it could be basically x1, x2, x3 till xk. So, what you are trying to do is that you are trying to basically break them into orthogonals. So, the minimum spanning would basically be given in 2 different directions. Those sets of orthogonals you are trying to find out would give you the best possible interaction, or say for example, the first and the second best possible combination of the orthogonals to give you the total effect. So, what you are trying to do is that you are trying to basically break down the overall effect in different orthogonal direction, because the interaction between the orthogonals will be 0, because 90 degrees, and you try to find out the effects of the orthogonals, sum them up depending on the concept of square error loss. Square error loss, if you remember, I did mention the example was basically the linear exponential loss function. That was nice practically, but theoretically square error loss was always utilized, because you want to penalize both overestimation and underestimation in the equal proportions and square them up. Now, if you come to these orthogonals which you are talking about, these orthogonals either in the combinations of y1, y2, y3 till yk with factors being alpha 1 till alpha k, and in another direction basically it will be x1 to xk with factors of beta 1 to beta k, would be done in such a way that you try to basically find out the minimum set of these orthogonals to basically predict the maximum amount of the variations. So, here where alpha i's and beta i's are the exponents of the first and second generalized interaction models respectively, with the convention that the first the non-zeros alpha 1s and beta j's basically they add up to 1. So, technically you will try to find out, even though it has been mentioned, I will just highlight it, even though it has been mentioned as k, need not be k, in the sense the set of x's and set of y's, so that the corresponding the sets of alpha i's and beta j's may be different, where I would say for example be from 1 to k and beta j can be say for example 1 to L, whatever the combinations are. So, through this you will find out the best effects in different orthogonals. So, the principal blocks, so basically you are trying to utilize some concept of principal component analysis. I will not go into the details for that. So, this principal block consists of treatment combinations satisfying the L1, L2 and so called this fx as the mod 3 level, the elements of this block form a group with respect to addition of the mod 3 modulus 3. Consider the 3 to the power 4 factorial design confounded in 9 blocks of 9 runs, and we choose the confounded as basically as ABC or AB square D square. So, what we want to find out is the overall effect. Their generalized interactions would be given as stated here. I will just highlight them. So, this is the first effect, and then I will use the highlighter color. This is the second one. So, these are the confounded blocks based on which you can proceed. The defining contrast of ABC and AB square D square are, here you will have L1, L2, x1, x2, x3 and x1 to x1 plus 2x4 would be considered, and you can take the combinations. For the 3K design in 9 blocks, 4 components of interaction will be confounded, and the remaining confounded components of the interactions can be determined by subtracting the sum of the squares for the confounded component from the sum of the squares for the entire interaction. So, you want to basically differentiate the overall effects into blocks or in confounded such combinations of ABCs depending on number of factors you have and the level of interactions each of them have, and based on that you can find out the best effect. So, in this case you have basically 9 blocks starting from block 1 to block 9, and the values, I will just mark the blocks as 1, 2, 3, 4, 5, 6, 7, 8, 9, and if you note down, so basically it would be, when I use the effects, so it will be as given as block 1, you will basically have the values as this. So, note down the numbers. So, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, from block 2 9, block 3 9, block 4 9, block 5 9, block 6 9, block 7 9, block 8 9 and block 9 9. So, this is basically for the 3 to the power 4 design, and based on that you can differentiate the blocks and do your analysis accordingly. So, your main task, if you remember, time and again I am mentioning, is basically to find out the maximum amount of dependence such that you are able to predict, estimate using these models, and such that the errors are minimized. So, with this I will end the 33rd lecture, and we will continue discussing more about this fractional factorial models in more details, the confounded, the blocks, the rollover effects, the folding effects in more details in the remaining 34th, 35th, 36th, 37th, 38th, 39th and 40th lecture. And obviously, in the last fag end of the last 2 lectures, or I will try to take the 40th lecture in such a way, so that I will try to summarize whatever we have discussed in TQM2. So, with this I will end this lecture and have a nice day. Thank you very much.